Hello, so today we're going to be looking at the area of a triangle. Now we're starting with this because this is the basis for all our other polygons. We can take any polygon as we've seen and separate it into triangles, because if you take triangles and put them together, you get any polygon. So we're going to actually start this off by something that you've probably have heard of. So the area of a rectangle, well, we just said we take triangles to make area of the polygon. So I'm going to split this up though, just along the diagonal there of the rectangle, okay? So I am saying that this is a rectangle, therefore these are 90-degree angles, okay? Well, how would you find the area of a rectangle? Most people have seen this throughout their life, and they will always tell you that, oh, well, the area of a rectangle is length times width, or it'll say base times height. Um, so I'll use the terminology for base times height because length and width, those are so interchangeable. Base and height are not when you're looking at a figure straight on. You know the base is the bottom. You know the height is how tall it is when it's perpendicular to that base. So I'm going to say base and height. And because it's a rectangle, that means this also has the same length as the base, and this has the same height as over here. All right. So we know then that the area for the rectangle would have been base times height. But we split that into two pieces, right? So how much is each of these triangles? Well, the area for each triangle, the area for each triangle would have to be half of that. So it'd be 1/2 the base times height. And if we put those two together, we get the rectangle. Well, this is actually the formula that's used for the area of a triangle, because you can take any triangles, combine them together in a certain way based off of one side. For instance, if I have that triangle and I draw an equivalent triangle to it. So these two triangles are congruent, meaning they have the same size and measurement. And if I put the congruent sides on top of each other like so, I get a parallelogram, which actually will have the exact same formula for area as the rectangle will. Because the rectangle is a parallelogram. So this means that no matter what, for my triangle, the area will always be found by 1/2 the base times the height, always. So that's pretty cool. Well, let's look at a couple of examples, shall we? You can pause here if you would like. Okay. So if you are given a triangle, and let's say it's a right triangle. Let's say that this side is going to be 7 and this is 24. Okay. How would you find the area of the triangle? Well, area would equal 1/2 the base times the height. Well, let's talk about height again. So height is how tall the figure is when it's perpendicular to the base. So it's based on it being perpendicular. For instance, when you go to the doctor and they test your height, they tell you to stand up straight, so you're not leaning back forward or anything like that. And when they say straight, they mean that they want you to form a 90-degree angle with the ground, because that way you're perpendicular. That way they can get the tallest that you would actually be. Because if you lean forward, your height's now gone down. If you lean backwards, your height's also has also changed there. So in this instance, we want it to be perpendicular always. So anytime you're looking for the height, you're looking for where it's perpendicular to that base. Okay. We'll see some examples shortly where you may have to extend a line in order to see where it would be perpendicular to it. Okay. All right. So let's solve for this area. So area would be 1/2 the base times the height. It's obvious here that the base is 7. So the base is 7 and the height is 24 because it's perpendicular to that 7. It's perpendicular to that base. It forms a right angle. It's 90 degrees there. So if we were to solve this, 1/2 of 7 times 24, and we end up with 84. And just so that we get used to this, I'm going to now put that this is 84 square units, or units squared, or square units. These are the same, unit squared or square units. The reason for that is because you need to be used to the fact that anytime you take the area, it is always going to have square units of measurement, always. Otherwise, it's not area, because it's as how we define area to be being the number of square units needed to cover the object. This is why this is important to always have here. Whenever you're doing your calculations, I tend to leave my units within, and we'll see some examples here, and I'll put units in so that you're used to that. I always put my units in so I can see that they multiply to give me my answer. They give me square units in the end. Because if they don't, then I must have made a mistake somewhere. Okay. All right. So as you can see with the right triangle, it's generally easy. It's very simple when doing this with a right triangle because you always have your base and height automatically given to you. Even if you're not, if you're given one of the hypotenuse instead and an angle, or if you're given the hypotenuse with one of the other sides, you can always find the base and height using trigonometry. Okay, and you can check out another video on trigonometry if you want some help with understanding how to do that. Okay, all right. But what about when it's like an acute triangle? So I'm going to draw this acute triangle here. The base has 6 inches. What is the height of it? Well, the height would be from this vertex up top going straight down so that it forms a 90-degree angle. Okay. Well, let's just say, for instance, that we have no idea what this height is. It could be given to us. I could just tell you what it is. But let's just say that we had no idea what it was. Okay. If we had absolutely no idea what the height would be, how would you be able to find it? Well, you wouldn't in this case. But let's say I told you that this angle here is actually 30 degrees. Okay? And let's say I say that this angle, let's do 60. Actually, let's make it a little simpler. 60 degrees. And I tell you that this also is 60 degrees. Well, what type of triangle is this? If it's 60 here, the last angle has to also be 60, which means this is an equilateral triangle or equiangular. Because with a triangle, a regular triangle is both equilateral and equiangular automatically. All right. So if this is the case, how would I be able to find the height? Well, I can use trigonometry to find the height. And because it's an equilateral triangle, I did know also that, make it a little bigger to see. When I draw this altitude, this height, it splits this side into 3 inches and this side also to 3 inches. And this angle up here would then have to be 30 degrees because this is 60. Okay. And so then I could use trigonometry. I could use a trig ratio in order to find out what is the height. Well, in this case, because I was given that this is 60 degrees, I'll use the 60. And I know that this is the height is opposite of it. And I have the adjacent side here. I have the 3 inches that's adjacent to it. Opposite and adjacent. Which trig function used opposite and adjacent? That's right, it was tangent. So I know that tangent of 60 degrees is going to be equal to my h, or my height, divided by my 3 inches. Okay. Well, using some algebra, I can solve for h by multiplying both sides by 3 inches. And so then I know that 3 times the tan of 60 is my h. All right, great. Now I could approximate that. I tend to wait to the end of the problem to approximate it because what are we actually looking for here? We're looking for the area. So we know area is equal to 1/2 the base times the height for a triangle. Well, we have 1/2, the base is 6. And what's the height? Well, the height is that 3 tan of 60, tangent of 60 degrees that we found earlier. And now I can plug all this into the calculator to approximate my value. So I get 1/2 of 6 times 3 times the tangent of 60 degrees. And when I do that, I get approximately 15.59 inches square. How did I get inches squared? Because the base had inches and the height also had inches in it. So inches times inches would be inches squared. Just like if you did x times x, you got x squared. Right? All right, cool. So that's the area of a triangle. If we have an acute triangle given to us, what about if it's an obtuse triangle? Okay, Well, I'll let you pause there. All right, let's look at an obtuse triangle here. Okay, so we have an obtuse triangle. Let's just say it's 120 degrees. Let's just say this is 5 inches here. Well, I see the base, that's quite obvious, but what is the height of it? Well, it may not be as obvious, but if I were to extend out my base, I could then draw a straight line, a perpendicular line to that base, and that would be my height. So in this instance, this would be my h. Okay? All right. So there may be times where you may have to use trigonometry in order to find out what is that. Well, we know that that's 60 degrees here. If we were given what this angle is, well, how do we know that's 60 degrees? Well, this is 180 because it's a straight line we just drew out. All we did was extend the line out, right? This would be like an exterior angle. So the exterior angle for 120 degrees will have to be 60 degrees. So just remember that exterior angles have to be supplementary with the interior angle. So this will be 60 here. And if I was given this line, I could do as we did before, use a trigonometric function in order to find h. For the sake of this problem, no, let's just say it's given to us, and let's just say we know that this is 3 inches. Okay? All right. So in that case, how do we solve for the area? Well, again, we have area will equal 1/2 the base times the height. And so that will be 1/2 5 inches times 3 inches. And when I multiply that out, 1/2 times 5 times 3 will give me 7.5. And I have inch times inch, so that's inches squared. So again, I have my square units. Okay, well, so that's the basis of finding an area of a triangle. We're going to look at 2 other methods, though, that are quite useful when dealing with triangles, because sometimes it's not always obvious what the height is. It's not given to you, and sometimes it may seem a lot more difficult than if it's an equilateral triangle or an isosceles triangle, where you can just draw the altitude and it splits the base. Sometimes it doesn't split the base perfectly in half. So what do you do in those instances? How do you solve for the area of a triangle because the height's not given? How do you find that height? So we're going to look at some examples of other methods in order to find it. All right. So that's the basis of finding an area of a triangle. I will see you soon.